First question says express w squared in the form x plus yi. So w squared would mean 2 plus 5i to be squared. Is everybody happy with that? Part 1. Then I have to multiply it out, which is 2 plus 5i by 2 plus 5i. I then multiply that out. I get 4 plus 10i plus another 10i plus 25i squared. Can anybody tell me what 25i squared is? Minus 25. So 4 minus 25 is minus 21. 10 plus 10? 20. Now, here's what they're asking you, okay? If I was to draw that on the Argand diagram, where exactly would it be located? Given that that's the imaginary and that's the real. So I have to go 21 to the left, and how much into the air? 20 into the air, and this would be the location of the complex number minus 21 plus 20 I. It'd be located at the point minus 21, 20. Everybody happy with that? Now, what the next question asks me is, if I square this complex number and then find the length of it, is it the same thing as finding the length of it and then squaring it? So I'll go through that again, okay? See the way the squared is in between the two vertical lines. Do you see that? That means that I have to find the length of the complex number that results when you square it. So it means I have to find the length of this guy here. Does that make sense? So I have to find the length of this one here, which is going to be find the length of minus 21 plus 10i. Does anybody remember how to find the length of it again, or the modulus? What's the formula? Square root of real part plus imaginary part. Where can you find that on your tables? You can't. If you learned it off that way, not using the distance formula, you won't be finding that anywhere on your tables. Okay? Exactly. So minus 21 squared, and that's a 20i. So minus 21 squared plus 20 squared. Put that into the calculator. Let's find out what it turns out to be. Square root of minus 21 squared plus 20 squared, and 29 is the answer. So the answer to this side is 29. We haven't found out the answer to the other side yet, have we? No. So can anybody tell me what does W with the square on the outside mean? Find it first, square it second. While in the first one it's square it first, find the length second. In this one here, it's find the length first and square it second. Now what are we finding the length of, guys? W or W squared? We're finding the length of W. Now W is, it says up the top, W is 2 plus 5i. It's going to be 2 squared plus 5 squared. And that in turn is the square root of 29 when you put it in the calculator. Now, what do you need to do after you get that? We've done this part here. Now, what's outside it? Squared. So, W squared is going to be 29. And we already know that the other one is 29 as well. Are they equal? Does the language tell us they're equal? The word verify that, does that mean they're definitely going to be equal? Show that and verify that definitely mean that they have to balance. If they don't balance, it means you made a mistake. Okay? Moving on. Question 30. Find the values of the real numbers x and y such that this side here will equal the other side. Suggestion, yes? Yeah, what about it? Find the values of these real numbers. So what would be a good idea to do here, guys? Any ideas what would be a good idea to start off with? Multiply them out. 3x plus 7i minus, what's this part here? I times minus 2y? minus 2yi equals, pay attention everybody, okay, what's next? Xi, and after xi, 2y plus 6 minus yi. Can I, class, tell me how can you make two equations out of this? Just, yeah, real, real, and real. So there's three real parts, and remember the location of the equal sign. 3x equals 2y plus 6. Bring the 2y over to your side. 3x minus 2y equals 6. Everybody happy with that? What about the next equation? Imaginary, I think is what that meant. Right? 7 equals what? Oh, sorry, yeah. So 7i minus 2yi equals xi minus. Now, did you need to put down the i's? No, because everything has an I in it, so therefore it's like saying 7 tables equals 5 tables plus 2 tables. Did you actually have to mention the word tables for it to be equal to each other? 7 equals 5 plus 2. Okay? That's basically why the i's don't even exist there anymore, because they're all the same object. Okay? Now what happens next, guys? Bring over the 2y, and what happens? 7 equals x minus y plus 2y. X plus y equals 7. Now, that can be spun into that there. Okay? Now, next part after that, guys, how would you get rid of which letter would you like to get rid of? I'd go for y. You can do either, but why is y easier? Because the y is a negative. In this equation, the y is a negative. In this equation here, the y is a positive. So if I just multiply this one by 2, what happens? 2x plus 2y equals 14. The two y's will immediately cancel each other, giving me 5x equals 20. X equals 4. What's the y value then? 4 plus y equals 7. Y therefore, which is 3. Now, after all that, we get x equals 4, y equals 3. X equals 4, y equals 3. Now, once we've done that, the next thing goes, explain why the complex numbers x plus yi and y plus xi are the same distance from the origin. Why are they the same distance from the origin? Okay. Now, just completely blank out the first answer. Okay. What does modulus stand for? If you say complex number z1 is x plus yi, and you say complex number z2 is y plus xi, can anybody tell me what does the modulus actually mean again? Can anybody tell me? So we have 2 points, z1, and let's for argument's sake call that z2. And these 2 points, just ignore the circle for a minute, okay? The reason I drew a circle is I can be guaranteed now that they're both the same distance away from the origin. Isn't that what modulus means? It measures how far you're away from the origin. Okay? Now, what's the formula for if they are the same distance from the origin? This would mean the modulus of z1 has to equal the modulus of z2. Would everybody agree with that? Now, what is the modulus of z1? It's the square root of the real part squared plus the. Now, what's the real part for z1? The real part is x. The imaginary part is y. So it's the square root of x squared plus y squared. What's it for z2? Y squared plus. So is x squared plus y squared the same thing as y squared plus x squared? So since they're equal, z1 must equal said 2. Hence, they're both the same distance away from the origin. Does that make sense? Alright. First question is, if x squared equals 9, show that the answer is x is plus or minus 3. Now, there's two ways of doing this. The first way is most people just go, okay, if I square root 9, the answer is 3. Are you looking, David? But the other answer can also be minus 3. Because minus 3 multiplied by minus 3 is plus 9. Remember, x squared means when you multiply a number by itself, the answer is 9. What are the two possible answers? 3 by 3 is 9, and minus 3 by minus 3 is 9. Now, another way of doing this is to bring the 9 over the other side and have x squared minus 9 equals 0. This is the difference of two squares, which is x squared minus, and then Moses might remember from 5th year algebra, that's the difference of two squares. And then you're going to get x plus 3 equals 0, x minus 3 equals 0, x equals 3, or x equals minus 3. Technically, this one would be the better answer for this question. Okay? Difference of two squares. Now that that's done, okay, what asked next is, what does this question reads, the modulus of a3, a plus 3i is equal to 5. Find two possible values of a. Yes. Just so I'm here, guys. X minus 3 equals 0. X equals minus 3. X equals plus 3. Okay. And now, after that, guys, what we're going to do for the next question is if the modulus of a plus 3i equals 5. Now, what's the formula for modulus again? Real squared plus imaginary squared, or the other way around, doesn't matter, to be honest. Now, what's the real part? A. What's the imaginary part? 3. You don't put in the I. Equals 5. Now, this is the square root of a squared plus, which is 9, okay? Now, what happens next, guys, is we have to figure out what a is. But the problem with figuring out what a is that it's locked in the square root sign. So can anybody suggest a way to free it up? Square both sides. If you square the square root, whatever is inside that square root is the answer. So if I square this square root, what'll happen? Just get a squared plus 9. And then I get equals 25. Bring the I'm going to do the difference of two squares way, but you could do it that way as well. I'm going to get a squared minus 16 equals 0. Sam, you would have got a squared equals 16. You would have square rooted it and you would have got 4 or minus 4. I will finish it off using the difference of two squares. And then a plus 4, a minus 4 equals 0. And then it turns out to be the same answer. A plus 4 equals 0, so that means a equals minus 4. A minus 4 equals 0, that means a equals plus 4. Is that right? 16, square root it to get 4. No. To it. Okay, guys, so we've done 25, 30. We're on 30, we've done 34, now we're on 36. 36 is the same deal. It wants me to do the modulus of both sides. How do I know that? The lines mean they want me to do the modulus of both sides. And then it also asks me to get two different values of q. So here's what you're gonna do. Square root of, anybody, what you do on each side? 4 and q, and the other one? 2 and minus 4. This one you're going to get 16 plus q squared. On this one here you're going to get 20 when you put it into the calculator. Just use the calculator, right? Now, 16, square both sides. What happens when you square both sides? 16 plus q squared equals 20. Bring the 20 over the other side and what happens now? Q squared minus 4 equals to 0. What can you do with the 4? Q squared minus 2 squared, and you're going to get q plus 2 minus 2 equals 0, then q equals minus 2, or q equals plus 2. Okay guys.